Hey everyone, so in this video we're going to go over what the properties of what two similar triangles would look like. So when it comes to dealing with similar figures in general, you're dealing with two shapes of different sizes and their sides are scaled the same way, meaning that to get to one side on one figure to its corresponding side, you need to multiply by something. And whatever you multiply by, it affects all the other sides the same way. So in example 1, you're given that triangle ABC is similar, this is your symbol for similar, to triangle DEF, right? So if you look at side AB corresponding to side DE, we see that it goes from 4 to 2, right? And remember, if we're traveling from one image to another, we call this our pre-image, and we call this our image, right? This is what we originally have, this is our result. Now, you can see that it goes from 4 to 2, 8 to 4, and 12 to 6, and that scale factor would have to be a multiplication of a half or a division by 2. Now, your question is, well, how can I determine that in general if I had something more complicated? Well, we can keep in mind of the formula whenever you're trying to find what we call the scale factor to get from one image to another. What are we multiplying by? The scale factor is always going to be the division of the image over the pre-image. Right. So if I want to verify that these two triangles are similar, I can say, all right, I can do side DE over BA, so DE divided by BA, and that's going to be 2 divided by 4, and that's going to be 1/2. I can also do side DF over AC. That's going to be 4 divided by 8. That's also 1/2. Now, normally when it comes to proving similar triangles, if you have two sets of corresponding sides that are proportional, then your third side is going to be proportional as well. But we can definitely verify that right now. So EF over BC is 6 over 12. We get, again, 1/2. So all of these sides have the same scale factor of a half. Let's look at an example like 2, right? Triangle FAR is similar to triangle BET. Now, we see that we have whole numbers here and decimals here, and it may look like they don't have a scale factor in common with the corresponding sides, but you need to check that out first before you can make that determination. So, again, we're going from here to here, right? So this is our pre-image. This is our image. And we want to determine the scale factor. Now, sometimes you're given figures that they don't look the same. Like, for example, in example 1, you had the two figures facing the same direction, kind of oriented the same way. In this case, it's not, right? So how would you ensure that you're mapping, right, that you're setting up ratios with the correct corresponding sides? Well, you want to pay attention to the ordering of the letters that they give you, right? A nice little visual trick that we show our kids is that when it comes to the angles, right, the individual letters, we can put symbols over them. So to indicate that F and B are corresponding, we can put little triangles over them. To indicate that A and E are corresponding, we can put squares over them. And to indicate that R and T are corresponding, we can indicate circles over them. So even if the orientation is changed, even if it was like reflected over, right? If you have these sides lining up, then you know which sides are corresponding automatically. So you can either focus on your letters by themselves, or you can use little visual reminders telling you, well, oh, I know because there's a triangle and square on this side, triangle square on this side, these two sides have to be corresponding. Just a little trick. So again, you want to make sure that your scale factor is set up as your image over your pre-image. So we're going to do 3.2 divided by 16, which was BE over FA. You can use your calculator. Okay, you get 0.2 or 1/5, which is 0.2 or 1/5. Let's do it again for another pair of corresponding sides. So let's do ET over, right, square and circle over AR, square and circle. So AR is going to be 1.6 divided by 8. And again, 0.2, which is also 1 over 5. Okay, I'm not going to do the third side. You guys can definitely do it on your own to verify, but this is pretty much a basic idea of how to approach similar figures in general, but specifically for this unit, similar triangles. Alright, if you have any questions, leave them in the comment section below, like and subscribe, and I'll see you guys later. Bye!